Now we are entering the first part of the section 1, the periodic table. We are talking about the stories about the periodic table. The periodic table we know today is shown here. We have many elements here arranged in many rows, but back to the ancient time, they don't know anything about these elements. So we have to go back to the ancient Greeks story. First, in 419 BC, the Greeks called Empedocles, he ever said that everything was made by 4 basic building blocks, which are the air, the fire, the earth, and the water. These 4 basic building blocks can be regarded as the 4 elements at that time. He says that the things can be broken apart to different building blocks, and then they can also be recombined to make new things. And the way to make new things is to do the actions of strife and love. Later, Democritus, he says that eventually I end up with something which cannot be broken up. After he cut something into small species. So this very smallest species can be called the element. In 17th century, Robert Boyle, which is the father of modern chemistry, he found many chemistry about the gases and invented the Boyle's law of gases. And he defined elements as a substance that cannot be broken down into any simpler substance. After that, Humphrey Davy, he used electricity to find out that he can speed up compounds to form other elements. At that time, he found the potassium in 1807. And later, he also found the element calcium and the cerium, and the magnesium and the barium. After that, Johann Dobereiner, he found some properties about the elements, and finally, that properties has been regarded as the so-called Dobereiner's triad, which says that for select groups of elements, which are 3 elements, they will exist certain traits of physical and chemical properties, such that there are so many elements, and he picked up 3 elements and arranged them with increasing atomic weight. And he found that the properties between these 3 elements has a rule, has a trend, and this trend can be shown in this table. On your left-hand side is the atomic weight for the triads of atoms, and on your right-hand side is the mean of the first, which is the blue element, and the last, the green elements. We add these 2 elements and divide it into 2, and the value will be almost the same as the medium elements, which is the red one. So in this table, you can see that we summarize the atomic weights of lithium and the potassium, which is 7 and 39. and divided it into 2, we will obtain 23. The 23 is just the atomic weight of the element sodium. He also found the same phenomena between the elements barium, magnesium, calcium, and also sulfur, selenium, and tellurium. Later, Newlands found some trend in properties, and he invented the law of octaves. This law of octaves says that the chemical and the physical properties of elements will repeat with every 8 element. This means that he arranged all the elements in terms of atomic weight, and he found that every element, that is HF, Cl, Co, Br, Pd, and I, they will have similar properties. The same properties can be found between the group of Li, lithium, Na, sodium, K, potassium, and Cu, Rb, Ag. This law of octaves has a similar pattern for every group, 8 elements, but this pattern starts to break down, which means not effective after the calcium elements. This is because some elements hadn't been discovered yet at that time. So at that time, he forced some elements into the wrong group, and then the properties cannot be the same with others. After that, a man called Dmitry Mendeleev, he created the first periodic table by grouping together elements in a certain way. This periodic table is just the formula of the periodic table we know today. The great thing that he made is that the periodic table he discovered can be used to predict the properties of elements inside the table, and even the undiscovered elements. For example, if he arranged the elements with atomic weight, and he found that the elements hydrogen, helium, barium, boron, and carbon can be just nearby together, and they are of the same group. So he said that there should be an existence of a helium element, because at that time helium is not discovered yet. So he can accurately predict the chemical and the physical properties of elements with very good accuracy. For example, at that time he invented elements with the name eka-silicon, which is like a subgroup within the group of silicon. And he says that this eka-silicon will have the same property as the silicon. And today we know that this eka-silicon is just the element germanium, which we know today. And the properties he predicts is just very close to what we know today. The difference between Mendeleev's periodic table and the modern periodic table can be listed in this table. The arrangement of the periodic table in Mendeleev is to make in order of increasing atomic mass or atomic weight. But in modern periodic table, the elements are arranged in order of increasing atomic number. And in Mendeleev's periodic table, noble gases is not included because some of them are not being discovered. But in modern periodic table, noble gases are included. Also, in Mendeleev's periodic table, there are gaps between elements, which means that he noticed that there should be elements, but he did not find these elements because they are not discovered. But in modern periodic table, there are no gap between the elements because they have all been discovered based on Mendeleev's periodic table. So that's the story about the periodic table.